Hmm. Hello, everyone. We're waiting for one more panelist to join. Uh, Hello, everyone, and welcome to Z.I.P Talks. I'm Sanath, lead programmer for Team 16290 Z.I.P Ties. I'm so happy to see all of you here and hope that you, your family, and your team are safe and healthy. Even though the pandemic is hindering our normalcy, let's all strive to stand together to walk forward on our journey through FIRST. Z.I.P Talks gives us a platform to share our knowledge and experiences with our fellow FIRST family. Now, I'm happy to introduce my good friend and lead builder for our team, Anup. Hi, Anup.
Hi, Sanath, and welcome everyone. In our first ever Z.I.P Talks, our presenters will go through the basics of creating a rookie team, documentation through the first engineering notebook, robot design, and programming. Welcome our presenters. Welcome Necromancers.
Hello, I'm Ben. I'm one of the co-team leads of Necromancers, and I'm going to be presenting the robot designs later on.
Hi, I'm Jolie. I'm one of the co-team leads from Necromancers, and I will be presenting Engineering Notebook.
Welcome Metamorphosis.
Hi, I'm Tom, and I'm going to be presenting robot design concepts.
Hi, I'm James. I'll be helping present robot design concepts.
Hi, I'm Gabby, and I'll be helping present the Engineering Notebook.
And then we're still waiting for a panelist from Super 7. Well, thank you all. Please post your questions in the Q&A section, and we will go over them as we finish each presentation. Now, without further ado, let's start off with rookie team basics. Back to you, Sanath.
Hello, everyone. We are 16290 Z.I.P Ties, and today we will be presenting to you rookie team basics. Our team is a second-year FTC team. We are based in Sanford, Florida, and we were formerly an FLL team, which stands for First LEGO League. We have 8 students from 8th grade to 10th grade, and last year was our rookie season. About First Tech Challenge. First Tech Challenge is the second highest level in the FIRST family, which consists of First LEGO League, First Tech Challenge, and First Robotics Competition. Teams compete in matches with an alliance partner, 2-on-2, using their robots to complete certain tasks in the robot section of First Tech Challenge. Also, teams give a presentation to their judges about their team and their season. This presentation is 5 minutes long, and also the judges will give questions for the team to answer. Teams also must submit an engineering design notebook for the judges to read. The essential steps of starting a First Tech Challenge are gathering team members, enlisting coaches and mentors, registering your team in the FIRST website, creating budget and fundraising plan, and gather team resources. When you gather your team members, you want to talk to people that are interested in robotics and First Tech Challenge. As First Tech Challenge takes a lot of time and effort to do, you want to gather people that you know will be committed to your team. Try to be diverse in your skill set, and because if you have your team that all are all interested in programming, then you won't have anyone to build your robot. So designate roles based on your members' skill set and also their personal interest. After you do that, you want to enlist coaches and mentors. If your team is a school team, your coaches and mentors may be some teachers from your school. If your team is a community team, your coaches and mentors may be parents of your members. After that, you must register in the first website. Contact your team members to register their team in their website. When you do this, your team also must pay a registration fee to be a part of First Tech Challenge. Your team also must gather team resources so that your team can be successful in your season. Your programmers can start learning how to program using different simulators. Your builders can start researching different drivetrains and attachments. And everyone can start creating templates for your engineering design notebook. Your mentors are a very big part of First Tech Challenge. Every team has a set of mentors that help them throughout their season. Many companies also require mentors for grants. So if you're planning on getting a grant for a company, you may require a mentor from that company. Mentors can bring many expertise to your team. They can help you with programming, CAD, organization, and presentation skills, and other skills that may be helpful for First Tech Challenge. Mentors can be anyone. They can be family members, friends, and colleagues. In fact, last year, my uncle helped me write some of my code from my program. Contact your coaches and team members of other teams or past season coaches. These people have a lot of experience in First Tech Challenge and can help you greatly throughout your season. For more help or expertise, reach out to the FTC community in the First Tech Challenge subreddit, which is reddit.com/r/FTC, the FTC forum, or the FTC Discord. When you start off your team, you should develop a budget and fundraising plans. FTC teams have to pay many expenses, such as team and league registration, robot parts, setup costs, which are field and tool pieces, game pieces, and miscellaneous items. As a rookie team, your costs will be much higher because you will have to buy many things for your first time. For example, you may have to buy robot kits, and you'll have to also buy your game set. You may not have to buy these for the upcoming seasons. FTC teams are encouraged to fundraise for their team's financial costs. You can do many fundraising activities, such as car washing, bake sales. You can also contact different companies to get sponsors. You can do this by reaching out to their company, by sending them an email, calling them, or visiting them in person. You can also apply your team for grants. There are many rookie team grants that can help your team succeed in the early parts of your FTC career. You can also enlist team member dues, where each team member must pay a certain amount of money for being in the team. There are a lot of recommended tools that you probably need for your First Tech Challenge. These tools will greatly help you when you build your robot. These tools include hex screwdrivers and Allen wrenches, which you're going to be using to tighten your screws. The recommended sizes for these are 7/64, 5/64, and 3/32. You may also need scissors, screwdrivers, a cordless drill, wrenches, needle-nose pliers to reach onto places which your fingers can't reach, safety glasses, which are required at every FTC competition and are a must for proper safety, a hammer, handsaw, a hot glue gun, a first aid kit, which is another must for proper safety measures, a laptop for programming and CADing, power strip / extension cords for use in competition, duct tape, and most importantly, zip ties. When you start building your robot, you're gonna need different robot parts. Your mechanical parts are going to be an FTC kit, which you can purchase from many locations. You may need spare motors or servos if you plan on expanding your robot, and for some cases, you may need linear motion, in the form of a linear slot. You also need some electronics. You may need sensors, such as a light sensor, distance sensor, and touch sensor, cables, such as the encoder cable, which allows you to detect how far your motor has went, power cables, which allow you to send power to your motors and servos, and servo cables, which allow you to extend your servo cable's reach. You also need different control electronics. Rapid expansion hubs allow you to interact with the different electrical components on your robot with the code. Your two phones or one phone, allow you to control your robot and run different programs on it. Your gamepads allow you to control your robot during the teleoperated period. And you need your battery to charge your robot and to give it power. There are many vendors that send these parts. The main ones are Tetrix, Rev Robotics, and ServoCity, and GoBuilder, all of which sell different FTC kits. GoBuilder also sells many popular motors to use. Hightech, another vendor, sells many popular servos to use, and AnyMark is where you're going to be buying your field kits, and they also sell different FTC kits. Throughout an engineering design notebook is a requirement for all FTC teams. It's a documentation of your season. There are three main sections for the notebook. Your summary, which consists of your team's history, team season, and important pages for judges. Your team and mentor profiles. All your outreach that your team does, and your business, which consists of your strategy and your sustainability plans. There's also the engineering section, where you put your engineering documentation, your programming documentation, and the team meeting summary. For more on the engineering design notebook, make sure to listen to Macro Manager's presentation right after this one. Each year in FTC, there is a challenge for a robot to perform. First releases this challenge, which consists of three sections. Each of them have a different task for your robot to score points. There's the autonomous section, where your robot has to run code that you have pre-programmed. The tele-up section, where you get to control your robot to perform certain tasks, and the end game period, where is a tele-up, which you can perform the task in tele-upper period, also perform more tasks to get additional points. First also releases two game manuals outlining the tasks and rules for competition. Game Manual 1 and Game Manual 2. Game Manual 1 contains all the general information that will be fairly constant throughout different seasons. This contains the rules for building your robot, your engineering design notebook, awards, placement, and how to advance throughout the season. Game Manual 2 contains all the game-specific rules about what the challenge is and how to get different points and penalties. Game Manual 1 for next season has already been released, so make sure to check that out. First also releases a video that explains the robot challenge for that season. Remember, this video may not cover the entire game, so make sure to also read Game Manual 2. In many regions, there are different formats. Here in Florida, we use the league format. In the league format, there are 4 main competitions. There are 3 league meets, which your robot performs different actions. You perform different games in order to determine your seeding, and the league championship, where you perform more qualification matches and then perform some elimination matches, where you determine what are the first place alliance, second place alliance, and other alliances. The winning teams from the elimination matches and also the teams that get high awards proceed to the state championships, in the Florida State Championships. Top teams there proceed to the first World Championships in Houston or Detroit. Here in Florida, we go to Houston. This year, Engineering Design Notebook is required at all competitions. So at each of your 3 league meets, you're going to be submitting your Engineering Design Notebook. In addition, at your league championships, state championships, and if you make it to worlds, you will also be required to do a judging presentation where you present your team and your notebook. If you have any questions, please contact us at teamzipties@gmail.com or ask in the Q&A section. Thank you.
Well, thank you, Sona. I don't have any questions. So next up is Engineering Design Notebook with Jolie and Gabby.
Hello, everyone. We are Team 4717, and today we will be presenting on the engineering notebook. A little bit of information on us. I'm Jolie. I've been doing FTC. This is my 7th season.
And I'm Gabby, and I've been doing FTC for 3 years.
So a little bit about our team. We were established in 2010. We're now entering our 10th season. We are part of the Haggerty High School robotics program, which contains 2 FTC teams, 2 VEX teams, an FLL Challenge team, 2 FLL Explore teams, an FLL Discovery class, and a Roboboat team. This is just a little bit of our award history over the past couple of years. You can see we've won Innovate and Inspire a couple different times and Think over the past little bit. Just so you know, this presentation has a couple QR codes, so feel free to take any pictures or scan anything. And if you want access to this presentation, feel free to email us at the end, and we can send it to you. All information in this presentation is based on the engineering notebook guidelines from last season. The guidelines for this season have not been released yet, so make sure that once those are released, you go ahead and read them, because it's really important that you get all that information.
So what is an engineering notebook, and why do you even need it? So engineering notebooks are documents that track a team's progress and goals throughout the season. Everything the team experiences throughout the season is written down and illustrated in their notebooks so that someone who was not there can understand what they accomplished and how they did everything. The quality of the notebook can determine which teams advance to the next competition based on who wins the judged awards. This means that the notebook is one of the most important parts of your season. We like to say if it isn't in your notebook, it didn't happen.
So when you are setting up your engineering notebook, you have 2 different choices. You can either have a handwritten notebook or an electronic notebook. So a handwritten notebook, you can print pages as print page templates and just write directly on them and then hole punch them and stick them directly into a 3-ring binder. Or you can purchase laboratory or spiral bound notebooks. And all of your entries must be in blue or black pen. You can't use pencil because that's erasable. It has to be something permanent. Book Factory is a personal favorite. I have used both handwritten and electronic notebooks. So if you're looking to get into handwritten notebooks, definitely check out Book Factory. They have a lot of great templates that you can purchase if you're looking into a spiral bound or laboratory notebook. Then moving on to electronic notebooks, you can use a cloud-based sharing site such as Google Drive, Microsoft Word. LaTeX, it's a typesetting program. Basically, you can program your notebook, make it look really nice, set up a lot of templates, and you can use Overleaf. It's cloud-based LaTeX editor, so you can work together as a team using LaTeX if you prefer to kind of set up like a set format. Or Google Drive is something that's really easy to set up as well. And of course, you would print those before competitions and put those notebooks in 3-ring binders. So the advantages to an electronic notebook is you can collaborate really easily. You don't have to worry about any bad handwriting if that's something you're afraid of. Engineers are known for bad handwriting. You have unlimited pages, essentially. You can just keep adding however much you want. You don't have to worry about reaching an end limit. You can have flexibility with design. You can kind of change your design over time and make it all flow really nicely. And they're generally pretty cost effective because you're using Google Drive and using our cloud-based storage. And you can correct any spelling errors that come up with lovely spell check. And the advantages to a handwritten notebook It's easy to write in while you're working. You don't have to worry about pulling up a laptop and having a bulky laptop next to you while you're trying to work on the robot or program. You can sketch directly into it. That's really easy. You don't have to try to like go through the process of scanning and cropping and putting it in. You have flexibility with design as well. You can draw directly into it and sketch a really nice design. It's pretty portable. You don't have to find a printer to print everything. You just pick up your notebook and go. You can input photos and sketches without having to scan them. And then some disadvantages that come with these for electronic notebooks: you have to have access to a computer or some technical device that you can record with. You can't sketch directly into it, of course. You have to scan everything. If you don't have a connection to Wi-Fi, you're not going to be able to access it. So if you're in a remote area where you don't have access to any sort of Wi-Fi, you're not going to be able to do any sort of editing. You're going to have to put it all in at a later time. It can be hard to change your format over if you're switching through different programs, because it's difficult to put a Word document into Google Drive and vice versa. And sometimes it can be expensive to print if your ink runs out. With handwritten notebooks, you can't have multiple people working in it at the same time. It's got to be one at a time. You can't have like 3 people standing over it trying to write at the same time. You have to worry about drinks and food spilling, as well as rain and tears. You can run out of pages, like I mentioned earlier. You have a set limit, and once you run out, you don't have any more room. You'll have to buy a second notebook. It's hard to correct mistakes, and of course, you can't use any whiteout in the notebook. So when you do make a mistake, there's a whole process you have to go through to fix it. Whereas with electronic notebooks, if you have like a spelling error, you can just go through and make that real quick change. They can be expensive to purchase sometimes, depending on whether you're getting like a laboratory notebook or a bound notebook. Those can be somewhat expensive as an upfront cost.
Okay, so though the whole notebook can seem overwhelming, there are some tips and tricks that can make it a little easier. For one, don't forget that notebooks are meant to be recorded in the moment. You shouldn't be going back to write about the meeting from last week. Plus, when you write your entries as you work, you're able to make them more detailed and accurate, and even include some of the things that judges look for, such as how your team overcame obstacles. Another thing that can be easy to forget is that you should record more than just the robot building process. There should be things like a concise outreach section, which can help you win awards like Connect or Inspire. Every team also has their own unique style when it comes to the notebook, so we definitely recommend kind of playing around with different formats and writing styles until you find what works best for your team and what you're trying to portray. Finally, how many entries you have it's important, but it's not as important as how good your entries are. You want to make good entries that communicate everything that you're trying to put forward, and ask yourself what you want the judge to take away from that entry that you wrote. So the importance of the engineering notebook. Why do you need one? Engineering notebooks. The engineering notebook is how your team communicates the design and build of your robot and your team's journey throughout the season to the judges and other teams who might be reading it. It is important both to win awards in the challenge and to gain skills that you might use in the real world, like anything from technical writing to cooperating with other people, to meeting deadlines. So there are several different required sections in the notebook that you should make sure that every notebook has, such as a team plan, team introductions, a summary page, and engineering documentation. Each of these we will be discussing in detail. And you can check out the engineering notebook guidelines there. So there are several different ways to go about writing a team plan. 3 plans recommended by FIRST are a business plan, strategic plan, and sustainability plan. A business plan is primarily in place to set fundraising and outreach goals. When creating a business plan, ask yourself what areas of outreach or mentorship is your team looking for, and create a concise budgeting plan. Strategic plans are similar as they outline what your team wants to accomplish over the short term and the long term. The best thing to do when creating strategic goals is to create a short-term goal, a long-term goal, and a sustainability goal, as well as outline how your team will go about meeting these. Finally, a sustainability plan outlines how your team will recruit and teach new members to carry on your team after the current group graduates. When writing your team's specific team plan, it's best to do all three of these or at least some combination so that you can show as much of your team as possible. So team introductions are kind of just a fun way to like bridge the gap between your team and other teams and the judges. It's like a window between you guys and the rest of the world. So one of the primary ways judges get to know teams is through their notebook. Team introductions can include small biographies about team members and mentors, and it can also be used to show some of the dynamics between members of the team, such as through quick anecdotes or quotes talking about fun times you guys had together. Some good stuff to put in your bios would be your age, interests, why you joined FTC. For example, some stuff that my bio says is that my name is Gabriella, I'm a junior at Haggerty, I joined FTC to try something new my freshman year, and I like movies, coffee, and writing. And no last names. So the summary page is a quick 1 to 3 spread detailing who your team is and what's happened throughout the season. It's kind of like a smaller version of your notebook or team plan, but it's really just like the page that the judges are definitely going to go for. So you want to just put out all of your best stuff on that page, such as pages that you want them to look through. But don't forget when you're kind of writing those pages that you want them to look through that you don't want to put too much, because if you have like a ton of pages for the judges to go through, then none of them are really going to stand out. So make sure to include your team name and team number and an overview of your season.
So the engineering section part of the notebook is basically your day-to-day activities. So every meeting that you have, it has to be recorded. And it basically includes all of your decisions and your overall journey, but with all those the judges want to see. So when you're in a meeting, ask certain questions that will help you with your writing of notebook entries. So what was your agenda? And then what are your next steps that are going to come after this meeting? What were the decisions that you made? And this comes from everything from your robot to your programming to outreach events that you've decided to do. How did your team make those decisions? Always emphasize the how and the why, not just the what. Judges want to see exactly what your thinking was when you were making those decisions. What was the impact that your decision had on the community, on your team? All of these questions, when you're going through and writing your entry, really help to make it more powerful and stand out. And always, of course, what is the next step? What are you planning on doing next? When you're formatting a page, make sure that your new entry starts on a new page every time. Even if your last entry ended with like just a little last sentence at the top, always a new page. Meeting number. You should all at the 14th meeting we've had so far this season. So you list every 10 where you met. Tasks and reflections. Basically, then go through and reflect on how and why you got them done. Make sure you include pictures and sketches to see exactly what your plans are with visuals. Those really help the judges when they're looking through your notebook to see why you did certain things or what your plans are. And any equations that you have or logical reasoning that you have, go ahead and put those diagrams in there too, because it really helps to showcase exactly what you want and what brought you to these decisions. And of course, make sure you have a page number down at the bottom and initial and signature of whoever wrote the entry, just to make sure that your page is complete. So these are a couple of the notebook examples that First has put out. So you'll notice that they have their team number at the top, they have the date and the start and stop times. They've divided up into tasks and reflections. And of course, you can use whatever names you want for those areas. And they used a lot of columns to create their stuff. And of course, they've got a page number down at the bottom. And you'll notice that it has a D, which you signal the start. Notebook 2, this is a handwritten notebook. The last one was electronic. So it's got the meeting number, it's got the date that it took place, it's got signatures down at the bottom of, who wrote the entry. the bottom, you can see that they also have page numbers. Notebook number 3, they've got their attendance, they've got the date up at the top and the duration. They've got pictures and they've got their tasks and reflections. Make sure they go through and analyze all of their tasks. And then down at the bottom, they have future details. And of course, the last notebook, they have their page number, they've got the meeting, the tasks and reflections, and of course that diagram. That's the great thing about handwritten notebooks, I will say. You can sketch whatever you're doing directly into it. And then of course down there, they've got the signature and the date that the meeting was finished. So you can see there's a lot of similarities and differences with these notebooks, and they all have a couple things that are really great to pull from, but they're all unique, and every team has their own unique take on how the engineering notebook should look. So additional suggested sections, these aren't necessarily required, but they do help make your notebook a little different, help it pop out a little bit. A table of contents. That helps you go through and scan exactly what people are looking for based on what they want to see. Outreach section. You can record all of the times and who attended those outreach events, what, when, where, why, how. Make sure you go into depth with those types of entries. Then you can have, outside of your engineering section, you can have like software sections that basically just go through and explain, have diagrams relating to that. Hardware as well, you can go through and explain each important subassembly on the robot and kind of just more in depth than just the overall journey that you had when designing it. And of course, there is a self-assessment that every team is welcome to use. First, put it out, and basically you can just go through and check off, is this in my notebook? Let me go double check. Let me see if I need to add that, and it really helps. The notebook is necessary for most awards. So of course, Think, that's the award that's based on your engineering notebook. Inspire is your overall well-rounded team. You know, they do well in all aspects, and of course you need a notebook to be part of that well-rounded aspect. Connect is connecting with your community and mentors around you. Of course, the Collins Aerospace Innovate Award. You know, you use your notebook, need the notebook to explain your design. Motivate, you know, working in, that's where that community section comes into place. And control, overall checking out how your robot is controlled in autonomous and teleop, and that's where that software section would come into play. And of course, it's not necessary for the Promote Award, which is an optional video award, the Compass Award, which is also an optional video award, and then the Judges Award that's given out based on the discretion of the judges at certain competitions. Quick tips, of course, don't forget these. Team name and number on the front of your notebook. They will throw out your notebook if it does not have your name and number on the front. It will not be pretty. Make sure you include it on the spine as well if you can. That way, when they have a stack of notebooks, they can look down the side and see where yours are without having to go and pick out every single one. White out. It's a hazardous material. Don't let it anywhere near your notebook. You don't want it there. Keep it away. When you have an error, you strike it through, write your initials and the date that you found the error. Mistakes, again, simple to fix. All you have to do, cross it out, write your initials and the date. No last names in the notebook. That was a new rule last year. They don't want to have last names anywhere in there. That does include mentors. So if you call your mentor by their last name, you can call them by their first initial. That works as well. You can only have 2 notebooks max. So make sure when you're writing, you don't, again, quality over quantity. Don't just fill up pages to fill up pages. You can only have 2 notebooks. The outside of your notebook must be less than 3 inches. So if you buy a 3-ring binder, make sure the outside is less than 3 inches. Ask yourself why when you're going through and writing your entries. You know, why did we do this? What was the purpose of it? You really want to get down into the details of your decision making. And never tab more than 8 pages. The judges don't have a lot of time to look through your notebook. So when you're tabbing pages that you think are really important for them to check out, don't do more than 8. That way you make sure that they can actually go through and check them. Failures are successes. Write about them. Don't leave out your failures. Failures are why you make decisions. Don't go backwards. Write about what happens in the moment. Don't try to go back 2 months before and say, gee, I wonder what I was doing on October 3rd. write about it in the moment so you don't forget about those important decisions that you're making. Your notebook is essentially a Lego instruction booklet. You want to make sure that if somebody were to come up, pick up your notebook and look through it, that they can build the robot from it. Pictures and sketches are worth a million words. You can describe all you want, but those pictures really help visualize exactly what you're trying to say. There's never a finished notebook, just like there's never a finished robot. You always want to make improvements to your robot. You always want to make sure that your notebook follows those improvements. So never just stop it because you think your robot's finished. Every meeting that you go to, make sure you document. Every event that you go to for outreach, document. Don't get overwhelmed, okay? Happen, having dinner at a meeting and you're writing about it. And there's always going to be at least one misspelled word. There just is. It always happens. Don't freak out about it. Just cross it out, move on.
Okay, so you can contact us with our contact information below. Our email is hhsrobotics4717@gmail.com. Our Instagram and Twitter are at FTC4717, and our website is hhsrobotics4717.weebly.com. So we have some questions in the Q&A section. So don't forget, if you have a question, you haven't put it in there yet, go ahead and put it in there and we'll do our best to answer them. So Anonymous says, do you document the tournament day in your notebook? If so, which section does it go in? We do. One thing that judges are really looking for is, where did you mess up and how did you overcome that, or what did you learn? So we kind of do like a lessons learned sort of thing after every tournament day. So.
Yeah, we actually have a competition section specifically for that. But if you want, you can put it directly in. Just engineering section is another meeting date essentially, and say, do you recommend having a few of the team members dedicated to notebook? Yes and no. You want to make sure that every single person on the team helps in some way writing some type of entry. But I would personally recommend having one person that kind of manages the formatting or a committee of people. That way, people can focus on just writing, and then maybe a couple other people can focus on making it look really nice and pretty. But do make sure that everybody has the opportunity to write something in the notebook.
Yeah, it shouldn't be just like the notebook person is writing the whole thing. It should be everyone.
All right, I don't see any more questions right now, so thank you guys.
Good presentation, guys. Next, we're going to be doing robot design with Ben, James, and Tom.
All right, so whoa, it's all the way back there. All right, so I'm Ben from the Necromancers, and we're going to be presenting robot design concepts, and I'm here with Tom and James.
So one of the most important parts of designing your robot is the engineering design process. It's a series of steps that many engineers use to plan out their products in the real world. It's especially applicable towards designing hardware components for FTC robots. It allows for a structured approach to create a product and the solution. These broad steps can help set your team up for success. It's very similar to the scientific method. So there are 6 major steps in the engineering design process. Identifying the problem, which is figuring out what the challenge really is. Imagining or brainstorming your possible solutions to the challenge. Planning, which is picking some of your best solutions and sketching them out to pick the best solution from those. Creating, which is creating a model prototype of the product to use during testing, which is the next step where you collect and analyze data from your prototypes. And then you finally move to improving your prototype, which you use your data to keep improving your robot and make iterations of it. So here's an example of how our team used the engineering design process last year to create our Skystone robot. So the first step, identifying the problem. We realized that one of the major scoring elements would be stacking the stones together to form your tower. So to imagine and brainstorm possible solutions, some of the solutions we came up with were direct stacking, reverse stacking, and then questions about the orientation of the stacking, which horizontally or vertically, and some possible mechanisms, which included slides, claws, or chain bars. When we planned, we decided to use the reverse stacking method and began to create sketches of stackers and intake mechanisms that would help us to achieve our goal. During the create step, we created CAD models of each component and successfully manufactured the parts for and assembled the robot. And during the improve step, throughout the season, we kept improving aspects of our robot, such as the drivetrain, intake, and reverse stacking mechanisms to improve performance. Although these are broad steps that can be modified for your needs, following this series of steps helped our team to create a highly competitive robot. For example, avoiding testing could have caused stagnation in our robot and limited us from performing well at competitions. Without brainstorming, our building process would have been way more time-consuming and inefficient than it actually was.
So now we're going to talk about the important questions you need to ask yourself while you're building your robot. So you might want to ask yourself, what must my robot actually do? And that's basically the objective or challenge of the game that year. So last year it was Skystone, and you had to stack the stones. So you have to think of solutions to stack the stones. You might want to ask yourself, how does appearance affect performance? Does the robot have to look a specific way? Certain scoring methods may require specific designs. An example of this was the Sky Bridge from Skystone. What materials are suitable for design? We ourselves use wood because it is cost efficient, but other teams also use metal or Delrin or other types or other products. What construction methods are important for this design? We use machining, laser cutting, and 3D printing to build our robot. And what are the likely social and environmental effects of this design? It isn't as relevant to FTC, but it's still important to consider in the real world. So there's certain awards related to robot design. The first one is the Innovate Award. It's given to the team that thinks outside the box and has creativity. So some of your craziest ideas might actually help you win the award. The Design Award is given to the team that efficiently uses parts with a creative aesthetic to their robot. So you want to try showing off your creative side for this award. The Control Award is given to the team that uses sensors and software to increase the robot's functionality. So you can use multiple sensors, encoders, odometers, and this will help your chances of winning the Control Award.
So one of the major things that we as a team do is called CAD, which is computer aided design. It's used by a lot of FTC teams, and it's helpful to determine if parts fit together, and as well as create custom parts to be 3D printed, laser cutted, or if you have access to CNCs, milling machines, all those other useful things. They work really well if you have it all CAD'd out. It can be used to show iterative designs because I'll talk about that later, that you can make a bunch of changes really quickly in CAD instead of having to like build out all of those parts, costing a lot of money. It's part of the engineering design process, which is part of the plan, create, and test. Some of the benefits of CAD is that it saves more money by checking if parts fit together in CAD instead of real life. So if you have a part that doesn't, like maybe a notch is too big to fit in a hole that you didn't see in the CAD, you can easily just change that in the CAD and put it all together to see if it'll work before you have to spend a lot of time manufacturing it, all the money manufacturing, and it still might not work as efficiently as you want to. As I said, it saves time of manufacturing many generations because maybe there are a couple big fixes that you can just. There are a couple big fixes that you could just change in CAD without having to print it all out and manufacture it. Of course, there's going to be some changes that you'll only know through testing, but some of the big changes that you'll see right off the bat that you can make it in CAD and it costs no money and very little time. You also have the ability to create custom parts. While off-the-shelf components are good and you can do a lot of stuff with them, custom parts allows you to make a more efficient and streamlined robot while also having like the ability to create more innovative designs. So because all of our previous robots could not have been really possible without our custom designs, because we have some mechanisms that just have to be laser cut or 3D printing. As I said, it allows for a more streamlined design as well as easy to see if different subassemblies will fit together. So if a subassembly is going to block another subassembly, like say your lifting mechanism will block your capstone mechanism, then you can see that in CAD and try to fix that. It's also good for the engineering notebook because the software looks really nice in the engineering notebook because it shows the process of you're designing and going through that journey. And then you see in the top right, that's one of our skeletons for one of our mechanisms. That it looks good in the notebook because it shows our process and it shows like we're thinking about a lot of stuff, and then we can transition that to the final part, and it looks good as that process. And some of the popular CAD programs that FTC teams use is we personally use PTC Creo. Other teams use SolidWorks, Autodesk Inventor, Fusion 360, and most of these have free education or student license. And some software out there also has licenses for first teams. So be sure to take advantage of those because they're free and easy to use.
So drivetrains are the core of your robot. To first build a drivetrain, you have to think about what type of drivetrain you'd like. The two major types of drivetrains are the six-wheel tank drive and the four-wheel mecanum. There are more types of drivetrains, but they aren't used as much as the six-wheel tank drive or four-wheel mecanum because of their cost and complexity to build. Utilizing the identify and brainstorming stages in the engineering design process, you will have to pick what type of drivetrain will suit your challenge and your needs for that year.
So one of the most popular tank drive configurations in modern FTC is the six-wheel tank drive. Using 6 wheels allows for tighter turns than a 4-wheel drive base while maintaining power and traction of a tank drive. It's often implemented as traction wheels paired with omni wheels or a drop center wheel. The drop center wheel will allow for more precise turning as it does not drag the other 2 wheels when trying to turn precisely. Tank drives sacrifice the agility of other designs for a greater speed and traction for games that require crossing the field quickly or pulling something. As you can see on the bottom right, that was our drivetrain from the Skystone season. We have a 6-wheel drop center tank drive, which allowed for high traction when moving across the field and made us resistant to defense.
So now we're going to talk about the four-wheel mecanum drive. So the four-wheel mecanum drive, as you can see in the bottom left, it has rollers attached to the circumference on a 45-degree angle to the axis of rotation. It allows for omnidirectional movement, so you can move in all directions. It has more forward-backward efficiency, and it can climb obstacles much easier.
So each drivetrain has their own advantages and disadvantages. Tank drive's advantages are that it's simple to design and build with very few moving parts, which allows for easy maintenance throughout the season. Tank drives also allow for high speed and can utilize torque very well to create insane speed and acceleration throughout the field. Tank drives are also resistant to defense, which can involve pushing from other robots. The disadvantages of tank drive are that it's less agile than other types of drivetrains, and it can only move in 2 directions without turning. On the other hand, mecanum drives are very similar. They are agile and easy to design and build. However, their wheels can easily slip, and mecanum drives typically require more challenging programs, and there's less interior space due to thick wheels.
So your robot's not going to be just a drivetrain. There's going to be other components. So for the Skystone season, we had maybe a lifter mechanism, a capsule mechanism, intake mechanism, all those different parts. So different sub-assemblies are designed to accomplish different aspects of the game and score more points. So some things to keep in mind when you're designing these is to simulate the amount of stress a part will have on it in CAD, as to not jeopardize the part breaking in the middle of match and subsequently hurting your score. So we've had parts in the past break during a match, and our robot was like useless after that. So we use this program called ANSYS, and you can see in the bottom it shows different stress points. So around that circle, this was just a test part I made. Around that circle, you can see it has a little deformation. So without this program, we would not have known, oh, that part can bend and squish there. So it's really good to know where your breakage points are. So you always got to keep in mind where the subassembly will go onto the robot, and whether or not this is going to be blocked by a separate assembly, or if you think the robot would be too front or back heavy, which throws off precision. So knowing where the subassembly is going to go is really important, and you can do that in CAD really well. So if your capsule mechanism is going to be blocked by a lifting mechanism, then that just makes the capsule mechanism useless. So you would want to simulate that in CAD and see, oh, this might hit it. I might have to change this without having to change it on the fly at a competition or something. And it just makes overall a more more efficient and more sound design. And conserving weight without compromising integrity is also important in different designs because it allows your robot to drive faster or the assembly to work faster and more efficient without without excess weight. So if you have a 30-pound drivetrain with with the same motors as a 12-pound drivetrain, that 12-pound drivetrain is going to go a lot faster and be able to score a lot more points. Where the 30-pound drivetrain could have saved some weight, maybe pocketing some of the parts. Because up in the this top picture, you see that we cut out a lot of like material from our parts because we can do that in CAD, and that saves a lot of weight, but it doesn't allow the part to break. It just makes things move a lot faster and more efficient, and not like being bogged down by a bunch of weight. So I'm gonna take you into the CAD. So this is our CAD for our Skystone season, and you can see that we have all of our parts designed and put together in this assembly. Oh, it doesn't like me. Yeah. All the parts put together in our assembly, except for a couple parts that we made later on in the season. So you can see our drivetrain. We only have to have one of them because the other side we can see what we call our skeleton. So that's where we can sketch everything and make sure it all lines up before we have to make the part in CAD. So it's just like another sketch that's easy to see what's gonna move, because you can see all the wheels here and the belt going around. But it's harder to see like the belt and the pulleys if you have it all together. You can see that the intake and the conveyor belt are really close together, and we could do that because we have CAD and we know, this conveyor belt's going to go here, and we know that it won't touch because we made the parts like that. You can simulate some of the components if my computer will let me. So we don't have this. It's not going to work. So some of the benefits of CAD is that you can move components in real time. My computer doesn't like that, so I try not to do that. But now it's breaking. But you can see you can have all the parts lined up and like work together nicely without finding that out after you built everything. And
So so control systems are the interface between the software and hardware. In FTC, you will need 2 phones and the Rev expansion hub, and all the wires connecting the sensors and batteries, etc. So the phones legal in FTC are the ones on the left side of the presentation. These are the ones legal for the 2020 to 2021 season. And then this is a picture of the Rev expansion hub.
all right, so now we have a couple questions. The first one from Anonymous: is it more important to design for autonomous or teleop? It really depends on the game. See, games like Skystone, it has a lot of autonomous capabilities, but it's not like if you designed it for teleop, it would already do autonomous things. But like a game for Relic Recovery or Rover Ruckus, that has a really important autonomous that it would be more important to maybe create a separate mechanism. Like if you have your teleop good enough, but you don't have any autonomous, you would like some autonomous, but with that, you don't want to really not have a teleop though, because it'd be harder to work with your alliance partners. Yeah. Do Ritom or James, you want to answer the next one?
Yeah. So next one asks, how much should a team prototype in CAD before they start building the robot? So basically, you want to build your entire drivetrain and all the attachments and everything beforehand. So you want to make sure it's working in CAD. You can obviously Ben talked about the simulation software, and you can use Creo or the different CAD softwares to use like prototype and stuff. So you want to basically have you want to make sure everything works before you build the entire robot together. Everything fits together, everything it works and like fits together.
But definitely, I would say prototype. Like if you have like cardboard or easy things to prototype, it because once you prototype, you'll have some of the big flaws that you can then once you do it in CAD, then you know, oh, this is going to be a big flaw that it would take a lot of time if you had manufactured it to like redo. So if you would prototype it with something that takes like an hour or something, then you know, oh, I need to I need to add a whole nother plate here because that won't work. So, and then Anonymous asked, what 3D printer do you recommend for precision and ease of use? I don't really know a specific printer, but basically anything that you can find that's like cheap enough. Not like super cheap because then you sacrifice some of the precision. But like really high-end printers, they'll give you a lot of precision, ease of use. But if not in your team's budget, you can always either get one yourself or find a local like university. Because we do all our 3D printing at University of Central Florida. So we go all we our mentor runs the lab there. So we go over there and we use their printer, which is really nice for us. But so you can contact your local machine shop or even get a small 3D printer if you need it.
So for the next question from Anonymous, should you design your robot to be able to do a lot of tasks, or should you design it to focus on less tasks that work really well? This actually depends on the game. Like for example, last year's game, Skystone, there's a bunch of tasks from moving the stones and then especially capstone versus not capstone. In this last year, we decided to have a robot be able to do the capstone in addition to stacking up stones. So we designed it for both because capstone was such an important part of the game. It could add so many points. But in other games, you may not want to do every single task. Like for example, our team in Velocity Vortex here, we chose not to get the big ball into the middle vortex and instead focus on shooting balls, which helped us to perform really well at high levels of competition. So really, it just depends on the game and what your team wants to do, and if you're able to achieve what you want with each mechanism.
So we generally go with unconventional designs because we like to play the game how it's like sometimes it's how it's meant to be, sometimes how it's more conducive to learning opportunities. Because we focus on a lot of how to learn. So last year we went with the reverse cycle mechanism, which like 3 teams did, and it's definitely unconventional. So we chose to do that because we thought, oh, this will be a really nice robot and a really nice opportunity to learn some things about automation and teleop and some things about like weight distribution. So we typically choose to go with those because they look nice. They help us learn stuff for the future, and sometimes they can score more points. You guys want to the next question?
So basically, yeah, we are part of the same school. The question was, how do you organize your team and program with such a large quantity of members? So what we do is what we're planning on doing this upcoming season is having certain sessions for the new members and trying to create videos and such to teach the new members based on our knowledge that we know.
We have a team. We have like a mentor, new member relationships, not mentor. We have an upperclassman, lowerclassman relationship. So if a lowerclassman, lower, I don't know, if like a new member doesn't know a lot and they want to learn more, they can always go up to an upperclassman and say, hey, I need help with this, or I need help just in general. They can they'll they'll help them along because they know once the upperclassman leaves, the underclassman needs to be able to like continue with sustainability. The next one is a 3D printer worth it? So we use 3D printers a lot, and a lot of our components. So I would say they are worth it if it's in your budget. You can create a lot of custom parts and a lot of them, like a lot of more efficient designs with 3D printers rather than just off-the-shelf components. Yeah, we haven't been as successful in previous years because, well, like from Rover Ruckus and Skystone, we weren't that successful because our our designs weren't really that good for the game, but they had a lot of learning opportunities and had a lot of like it it was how we played the game how we kind of wanted to play the game, and the previous years that were successful, we focused on, oh, this is going to work and it's a little bit outside the box. Velocity Vortex was our most successful season. We made it to finals at Worlds, so we had a more conventional design. Besides the not going cat ball and just focusing on a bunch of shooting. So, but in the previous years, we've also had some team conflicts that we've kind of communicated through, and but that kind of hurt the robot design. But we communicated through that, and we're seeing improvements in it.
So it's not really required that teams do an autonomous program. You can have your robot sit at the start until teleop starts, but if you want to score points and compete at higher levels, an autonomous program can definitely net you 50 or 60 points early on.
So all of our CAD designs are in our notebook. We have a separate section called the just at the end of the notebook called the custom parts reference. That it's just every part we've used in like a drawing of it, like the CAD drawing of it. So it just shows, and we reference it in the engineering section. We say, oh, if you want to see a more detailed picture of this, go to this parts reference, and you see, oh, this is what it looks like. And what was I gonna say? Yeah, whenever we make a part in CAD, we always include like a screen snippet of it and just put it in the meeting where we have it and say this is what it's going to look like and what we think is going to. So answer this one. So Anonymous asks, how will you guys tackle the notebook if it does end up being a 15-page all online submission? Well, I haven't heard about the 15-page thing. I might just be uninformed. But if it's all online, then we already have our electronic copy and in a PDF, but so we can just submit that. But if it is a 15-page, then we'll just have the things that highlight your team the most. So if you do something completely different from the teams, like if you do an outreach event that you haven't seen anyone else do, you would want to include that a lot. And if you have a design maybe that is different from other people, if you want to include that in like your team's journey, kind of really important. So if you would want to document that as well as the required stuff about the team summary and the engineering and the appendices in the bios. So that's how I would do it if it was only 15-page online submission. You just want to highlight the stuff that kind of makes you different and how your team has kind of evolved.
Ben, just to add on to that, we do have a vote team through our program, so we have a little bit of experience in cutting down like a year's worth of information into a smaller format. So basically, if you did have to have only a 15-page submission, you wouldn't go through and have like in-depth, here's what we did at each meeting. Basically, what you would do is probably give an overview of your entire robot, go into a little depth about each of your sub-assemblies, give some like overall ideas, and then just really focus on the like main things you want to get across because you don't have a lot of space to put everything in.
All right, does anyone have any more questions?
Okay, well, thank you. Thank you, Ratam, Ben, and James for your presentation. And next we have programming section with Rohan from Super 7.
Hi guys, can you guys hear me okay? I'd assume you can. Yeah, all right, cool. So my name is Rohan Trevorella. I'm the lead programmer from Super 7. And a little bit more about me. I've been doing FIRST since like in 5th grade. I did FLL until 8th and then FTC until now. And I'll be a high school senior next year. So let's get on with the presentation, I guess. Let's see, 1 second. All right, cool. So yeah, this I just get introduced myself. So I'm from team 7477 Super 7. So this is all information from our team last year. A lot of our team members are graduating this year, so we're still a little bit undecided on who's on the team, who's not, how all of the logistics are going to work. So we were 12 students from 7 different schools. We're based in Oviedo, Florida. We had a wide range of students from 7th to 12th grade. So this is just a timeline of what's called the events that we've participated in, being that we've done FLL from 2010 to 2013, and we've been doing FTC for 2013 to now. So we've qualified for the World Championship for the past 6 consecutive seasons, and we've also helped mentor Z.I.P Ties and Cyber Knowles last season. That would be. So this is a fairly old team picture, but as you can see, clearly posed in the middle is our team dog Ace, the most valuable member of the team. He's also our team mascot, and we often name our robots after Ace. So, okay, so now on to the fun stuff. Woo, programming. All right, so just an introduction to FTC programming. So the programming that you're going to be doing in FTC is mainly done through Android Studio, and you're going to be writing in Java. Java may be unfamiliar to a few of you. Some of you may have heard it. Some of you may even like know it through like CSA or another class. But the Java that you're going to be doing is pretty similar to everything else that you've been doing, with just a few nuanced kind of differences. So just a basic overview of how you download them. So programs that you make are downloaded onto your robot controller phone. As you guys know, you have a driver station and a robot controller phone, each of which communicate within each other, which allow you to control your what's happening with the robot. So from there are 2 different types of programs that you're going to be making in First Tech Challenge. There's the autonomous program and the teleop program, as many people have mentioned before. So the autonomous programs are pre-programmed instructions that your robot runs and uses sensors and other control mechanisms to determine its location to ensure its reliability. While teleop programs are programs where the drive team is directly able to control the movements and actions of the robot and the various modules on it. So this would coincide with where you see the people picking up their controllers, driving their robot around, stuff like that. All right, so now on to setting up your Android Studio environment. So there are 3 things that you need to do. This is for people who have never programmed using Android Studio before. So if this does not pertain to you, it might help in that some of the situational kind of things might have changed since a lot of things are being updated. So you should always try to stay up to date on your FTC SDK. That's very important. So in order to set up your programming environment, you need to install 3 different things. And as I said before, you should always be downloading the latest version of each one. You need to download Android Studio, since that's going to be your development environment that you're going to be using to program your robot. Your Java JDK, since that's going to allow Java to run on your computer and for your Android Studio to recognize that like it's running Java. And then your FTC SDK, which provides you with all the first provided materials, examples, and all the libraries in order to program. So once everything has been downloaded, you need to unzip the FTC SDK into the desired folder and open it using Android Studio. There should be an option through there. And then this process, if done correctly, should be fairly easy. I know a lot of people have had some issues, but those issues arise when you don't have all the necessary components when downloading Android Studio. So if you do, it should just give you some error reports that you should be able to hit like the recommended solution on the Android Studio, and it should fix itself. So that's not too hard of a task. So once that installation process is completely finished, it should look like this layout I have here on the right. So if your installation doesn't look like this, make sure that everything has installed properly. Make sure that your Gradle, which is what kind of builds the project, make sure that has finished, completely finished. And one thing that might happen is that you might be on a different window when viewing it, as you can see right here in the top left corner. So switch that to Android and see if everything's built correctly. If it does look like this, then you'll know that everything has been made properly. So now more details about the types of programs that you're going to be dealing with. So as I said before, teleop is a driver-controlled period, and this is where the drive stream is able to control the movement of the robot. So this period lasts for 2 minutes in an FTC match. And then this comes after the autonomous portion, which, as I said before, was pre-programmed instructions that uses sensors and other control systems to determine positions. And the autonomous portion only lasts 30 seconds in a match. So once you guys are going to get started coding and you have your Android Studio environment set up, this is what your programs should kind of look like. So this is up here is the autonomous portion, and this right here is the teleop portion. So as you can see, there are a few differences. Don't worry about these like package statements and import statements, since those will be automatically generated by Android Studio. So as you can see here, the first difference is that this is at autonomous and this is at teleop. The text right here defines the name of the program and the group that it'll show up in on your phone. So try to put pretty descriptive names so you don't know what your programs are. Now, this right here, this public class autonomous sample or teleop sample, this autonomous sample and teleop sample, the names themselves are the names of the Java programs that you have. You can delineate those yourself. That's what you choose, and that's all up to you. So extends linear op mode. So essentially, linear op mode is a linear way of running through a FTC program. So what this means is that it first does what's first in the program, then does what's next, and then does what's next. So there's also normal op mode, but I've preferred to use linear op mode. You could look into it, but I just think I just like linear op mode better. So now you get to this public void run op mode. So this should mostly be auto-generated for you. When you make your class and say extends linear op mode, it'll have a red squiggly underline for the class header over here. And when you hover over that, you'll be able to just implement this method right here. So this stem shown right here should show up for you guys automatically. So what this means is that this is the method that's run when started. Like when you hit that start button on your program, this is the method that's called. So, and there's also this line of code called wait for start. So that just waits until you actually hit the go button on your phone after initializing. So that's very important to all of your programs and can be a major thing that causes your program not to work. I've seen for many rookie teams, they forget to put their wait for start. And even though their code may be perfectly done, the lack of the wait for start causes their program not to run properly. So yeah, and then for the teleop, it's pretty much the same thing, except in this instance, you'll be taking inputs from your gamepad, which you would reference using your, what's it called? Yeah, just the gamepad object itself. So in order to control your robot, actually, you need to create a configuration file. So what are configurations files, you may ask? They're files on your robot controller phone that can either be created on the driver station or robot controller phone that specify where a program needs to look to find a specific module. So this would mean that you would type in a specific motor name in your configuration file. So they can only be created once the entirety of the robot has been wired accordingly and connected to the Rev Hub, meaning that you can't do this, you can't make a configuration file before the robot has been built, pretty much. And when you're naming your devices in your configuration file, remember to use descriptive names that indicate what device it represents. That's very important, since when you're building robots in FTC, you're going to be dealing with a lot of devices. So this may cause your code to be cluttered and even at times unrecognizable, because there'll be so many junk names in there. So yeah, now on to initializing hardware devices. So this is sort of taking what you just
Looks like Rowan's having some technical difficulties, so let's just wait for him to get his mic back working.
Hello, can you guys hear me? All right, cool. Okay, so I think I cut off when I was talking about the just the layout. So that's how you initialize and declare an object in Java. So the type of object would be the type of a hardware device that you're looking at. So in this case, it would be a DC motor. So you'd put DC motor, and then whatever you want your motor name to be equals hardware map dot DC motor, since you're looking at a DC motor currently, dot get, and then you would put the name that you have in your configuration file right here. So the same thing for servos, same thing for sensors, and there are lots of different types of DC motors, servos, and sensors that can be that exist within the Java libraries for FTC. But most of them, almost all of them, actually follow this template. So if there is a specific hardware device that you don't know how to initialize, the SDK provides an examples tab demonstrating the how to use how to use and program different sensors. And this also applies for the camera, which may seem like a lot more complicated, but the code is already all there in the example section. Okay, yeah. So now let's move on to more specific sections. So the autonomous section. One thing that you need to do in your autonomous section is that you have to make sure that your autonomous is reliable. You don't want an autonomous that works like half the time, like flip a coin, if it's heads, it works. You don't want that happening. When you try to like sell yourself to other teams, when you're trying to get picked to be in the finals, you want to say that your robot can be reliable. And you also want those points when you're qualifying. So within the autonomous portion of the run, many different control systems can be used to ensure that it's reliable. One of them being time-based movement, encoder-based movement, odometry mapping, and image location determination. And within those systems, each one has their pros and cons, but the odometry mapping and image location determination are much more complex. They're still doable for rookie teams, but they're a lot more complex, and they probably should be avoided until you get more experience with it. You can definitely check it out. So time-based movement. This is like pretty much the simplest form of autonomous movement you'll be able to find. So it's really, really easy to program, and it's honestly more reliable than dead reckoning because there's not much you can do with dead reckoning that you can't do with time-based movement. So the cons is that it's not reliable when compared to other systems, and due to this, the fact that there's so many factors that can affect it. For example, the behavior of those programs can change based on the power level. So say you're testing your robot out at your field with 100% power. So your robot's going to move a lot faster, everything's going to move a lot smoother. But then you go to your field and you end up with like 80% power. Your robot, even though it's moving through the same amount of time, it's going to be moving at a slower speed, and subsequently it'll have a different behavior. So that's not very reliable as a whole, since autonomous can require a lot of precision, as the tasks within it may take like specific complex intricate movements that the robot has to do. So then now we're moving on to encoder-based movement. So some pros for it are that it provides a fairly reliable position of the robot, meaning that like using your encoder values, you can almost always know where your robot is. Like it's not exactly precise, but it's leaps and bounds better than what the precision that you can get with time-based movement. So also, encoders allow for the accurate and precise control of robot modules. This just doesn't have to only pertain to your drivetrain. It can be used to control your linear slide, certain other horizontal slides, or like other movement mechanisms that you have. So some cons that come with this program are that it can be slightly more advanced to program, meaning that it's not always like super easy like time-based is. Time-based should take like a few minutes pretty much to make a whole autonomous program based on time-based movement, but encoder-based movement can take days or weeks or some amount in order to get properly. And another con is that it's not perfect, and that goes for all movement systems actually. None of them work 100% of the time. All you're trying to do is make it as reliable as possible. So some errors that can arise when using encoders are that your wheels can slip when hitting the ground. This causes for the encoder ticks to be overestimated, or if your robot is hit, they can be underestimated. So it's not exactly 100% reliable. So now I'm going to talk about tele-up control systems. So this is where you yourself are controlling the robot. So the main way to drive a robot is through the use of a tank drive layout. So this would mean that the left joystick on the controller controls the left side of the robot, while the right joystick controls the right side. This would mean that both forward means go forward, both backwards, one up, one down makes you turn. It's a fairly simple control system to learn. And many of you who have played like video games might have encountered this type of control system before. So it's not too hard to get used to. So this control system is good as it allows for drive teams to have a lot of control over the robot, but also leaves a wide variety of buttons and triggers that can be used to control other modules on the robot. So some other control systems may use like buttons or triggers within themselves in order to like drive the robot. But with the tank drive system, all you need to drive it is the two joysticks. So this is actually the only control system that I'm going to be talking about, since most of the other control systems are suited for different types of robot building, meaning that they're more complex and stuff like that. There's like the sort of first-person control system, as I like to call it, or there's the field-based control system that's possible with special wheels, such as Mecanum wheels or specially mounted Omni wheels. But those are a lot more advanced, and I'm not going to cover them right now. So that's pretty much it. Does anybody have any questions? I'll check the Q&A in a second. And if anybody has any additional like questions or information that they want regarding programming, feel free to contact me at my email right there. This goes for any part in the season, not right now. Like if you're having any issues getting your program to run, just shoot me an email and I'll be sure to respond. All right, so let's get to questions. All right. For a rookie team, how do you prepare your team? All right, so as a team that as a community-based team, we have some like challenges when it comes to organizing ourselves. So I feel like my situation is similar to yours. So the way in which we do it is by pretty much setting a schedule for when we're going to do things. So like whenever we have our game release, we always have like a call after to discuss ideas and brainstorm. And following that, we decide when we're going to meet, how often we're going to meet, and who's going to be coming. So in that way, we're able to determine who needs to be there and like the amount of work that's going to be done in what time period. So you're asking, and for off-season resources available for CAD or programming for rookie teams. Actually, if you just search on YouTube, there should be like, I'm pretty sure there's like hundreds of tutorials regarding CAD and programming. But also remember that you can always reach out to other more advanced teams. There's always a lot of people around you who are happy to help you at any time. So I think that answers your question. Okay, so how much time should you dedicate to programming tele-op versus autonomous? So personally, I believe that autonomous is quite a bit more challenging, since this is a portion that's entirely reliant on your programming. So I found the tele-op portion taking me less than like a day to do. Maybe a few more like advanced systems took me a little longer, but the tele-op portion did not take me much time at all. The autonomous portion is pretty much what you spend your time on. But you don't want to sacrifice the integrity of your tele-op program for your autonomous program. It's always important to make sure that you can accurately control your robot before you start on your autonomous. If you can't even drive your robot in tele-op, you shouldn't be touching autonomous yet. So I would recommend making your tele-op first and then spending all the time you have additionally to your autonomous. And then from there, you can make tweaks and adjustments based on like driver's preferences and things like that. So that should be good. So how important is odometry? Well, having used it last season, I actually didn't like it that much, if I'm being honest. It wasn't that much more reliable than encoders. Like, for example, a team called Neutrinos at the state championship, they were using an encoder system and often had a more reliable autonomous than us, than our team did. This is mainly due to the fact that odometry is also suffers to the same problems that encoders do, in that it also can slip and it can mess up the position of the robot on the field. So that's a lot of what we were having problems with, and like it got really messy in the end trying to fix those drift and slip problems. So I would say that it's not that important. Getting a reliable, like autonomous based on encoders should work the same as odometry for all intents and purposes. Maybe for like super high level, like gluten-free type of auto, odometry is really important. But like for pretty much any other like non-crazy auto, encoder should suffice. So is there any way I can test programs without a physical robot? I'm not entirely sure, but I'm sure there are ways. Like I know there's something called like Roadrunner you can look into. It's a little bit more complicated though. And it might not always accurately represent what you'll see with your physical robot. And that's another thing with programming. What you program is not always what your robot will do. Like I've experienced this more than like uncountable amount of times pretty much. Your robot does what your robot wants. Like one run you can do it, it'll run a perfect auto, and the next run, the same exact program, nothing changed, and it'll completely fail, it'll bash into every single game element. So I would recommend, I mean, yeah, there are probably ways that you can test it, but I would recommend just sticking with your physical robot when programming. It's best to try on that. So
just to add on to what Rowan was saying, if you're a rookie team, like sometimes you may want to be starting programming before your team has the parts for a robot or even has a robot built. So there are different simulators that you can use. If you want to, you can email our team. I can send you the link to one of them. What you can do, while they may not like have the different like nuances that your robot might have, they're a good way to get like introduced into programming and FTC programming and basically see how everything works.
right. Also, to add on to what Sonat said, rather than programming for the actual robot, you could also make your outlines. So an important thing within like programming big projects like this is to have is to be organized pretty much. So to have a good class structure and to have everything in a way that you can easily edit it. So what I do, I have like a base program, and then I have a tools program, and then I have another, like the actual program itself as my class structure. But that's completely up to you. But I would recommend, if you have like time before or like free time in general, try to make your system more organized. So who decides what is programmed and how do you balance the decisions between all team members? Okay, so as a programmer myself, I believe that like it should be up to the programmer to see what they can do, because every single person has their limitations and things that they can't do. Sorry about that. So every single person has things that they don't know how to do and things that they are good at. So one thing that I found within like a group of programmers, they can often do things that like one person can't do, but like it should always be based on what your programmer says. Like if your design team is trying to give your programmer like a super complicated odometry system to use, and your programmer tells you that they don't know how to do it, you should not go ahead and do it. You should stick to your encoders and stick to what you want to do. So when it comes to programming, it should be the programmer themselves who has the final say in things, because you're the one who's actually putting the work in to do it. I'm assuming that you're a programmer also who's asking this question, so I'm just gonna talk to you like that. So your next question was, how do you balance the decisions between all team members? Well, as you know, there should be different teams, like as they mentioned earlier. So like different management teams, and there should always be like somebody who's like the lead of something. So depending on what kind of decision you're making, I believe that it should be more the team that it most heavily involves should have the biggest say in the decision. So like if you want to change the design of the robot because you don't like it and you're on like the programming team, you could convey your ideas to the design team, but in the end, I believe that it should be the design team's opinion that goes through and doing the end, because they're the ones doing the work again. While I do think that certain things should also be a team decision, like big decisions, for example, like should we change our robot completely for the next competition? That should be decided as you and a team and your mentors. So one way we like doing that is by taking our best two options and making a pros and cons list for each one. And then from there, if we still can't decide what we want, we try prototyping both of them, comparing how the systems work, and then going from there. So I think that should answer your question. Okay. Do you require more than one programmer on the team? Require is a funky word. So you don't require more than one programmer on a team, but like it's a good thing. You don't want to overwork somebody. And having more than one programmer is always a good thing, since if one person can't do something, they can always go and ask the next. And in the situation where there's a really advanced programmer and there's somebody who has barely any clue what they're doing, it's still helpful to have them around. As like you can give them menial tasks that you don't want to do, things like cropping pictures for like images or stuff like that. So it also goes to the fact of like a team consistency. So once that one programmer is gone, there's going to be no more programmers on the team, and that's not a good thing. So it's a good thing to have more people on it, as they can learn from a main programmer, and they'll be able to carry on the team. So that should answer your question. And I don't see any more. Does anybody have any more questions? Yes, no, maybe so. All right. Sanat and Anoop mentioned that various expenses may be big. Oh, various expenses may be a big deterrent for new teams. What fundraising ideas have you done that have been successful, and/or are there any ideas that you think a new team could use? Okay, so the most important thing for getting fundraising is getting grants and of reaching out to sponsors. So like, sure, you can do like fundraisers like selling Little Debbie's, but that's going to give you like $100. The main way in which you get like money for FTC is through talking to people, talking to companies. And you shouldn't be afraid to ask the company for a support, even if it's not financial, actually. So in regards to fundraising ideas, I would recommend just talking to professional companies and seeing what they think on the matter, and seeing if you can get help from them, and help in any way is useful. Like, we have a sponsor named Dot Decimal, who, even though they don't donate to money to us, they help us machine metal parts. So we're able to CNC things, and that's the only way we could do it. We otherwise wouldn't be able to make the robot that we did last year. So, and since you're a new team, a lot of people don't know like that your team exists yet, right? Because you're new, right? So you want to make sure to get the word out. Like, try to send as many emails, try to send as many newsletters, try to send as much as possible to people. You just want to get your name out there, pretty much. The more people you talk to, the better. It's never like I talk to this many people, I don't want to need to talk to anybody else kind of thing. Just try to like, what's it called? Just try to get as much support as you can. So that should be good. Any more questions? I don't see any.
Okay, so if anyone has any like general questions for any of us, just you can just type in the Q&A, and then like whichever one of us wants to answer it. So where can we find this presentation? So at the end of this presentation, the Zoom is being recorded, and it'll be posted on our YouTube channel, which is FTC 1690 Z.I.P Ties, and all of the individual PowerPoints will be in a Google Drive that I will share with you. Would you recommend a new team to try to go to as many competitions as possible, or should they focus on getting familiar with how FTC works? I would suggest that every team should go to every competition that they can go to. Like I said in our presentation, there are 4 main competitions in the Space Coast League, the 3 league meets, and then the league championships. I would really suggest going to each one of those league meets and the league championships. Not only that will it help you with your ranking, it'll provide a really good experience for you. After like, when we came to our first league meet, we were completely confused about like how everything works. But as we went through the league meet, we started to realize how the league meet works, and then in the second league meet we were prepared. So I was just going to as many competitions as possible just to get that experience. For team recruiting, the question was, do you have any tips for team recruiting? So one thing, if your team's part of a school, then you can start it as a club in your school. I don't know how your school may do this, but for our school, you have to find a teacher to be a sponsor for that club. And doing this, you can get permission from your school's principal to maybe put up some flyers for people to join your team. If you're not part of your community team, then you can ask people that live in your neighborhood, or people that go to school with you, or just many types of people. Like when we first started our team, uh, like we had Anu was one of my good friends and from school, and I just asked him, "Do you want to be part of a team?" And he said, "Yeah." So you can just ask different people that are in your area or into your school. How much how much time do you recommend a rookie team should spend during a school year? Uh, During the school year is when a majority of the season takes place. The season starts around like September to February, like early February if you make it to league champs / states, and then April if you make it a worlds. I would say that like our team, we had 3 meetings a week, 3 hours each, Wednesday, Friday, Saturday, or Wednesday, Friday, Sunday. I would suggest meeting as much as you can, but don't slack off on your school. Meet, yeah. Otherwise, your parents will get mad and probably stop you from going to meetings. You want to like some things you can do from home with your notebook, but some things such as building a robot or testing your code, you have to be in your meeting to be at the place where your field is. So I would suggest spending a good amount of time in robotics. Robotics is a big commitment. So that's why when you recruit members, make sure that they will be committed to your team. Is diversity important in a team? Do you mean? I would say that it's good. It's good to be diverse, but like don't just like recruit people for the sake of being diverse. That's what I would say.
I would say for that question is how many members are ideal for a rookie team or for a non-rookie team. The max for an FTC team is 15 members. So our team has 15 members, but a rookie team is basically however many people you can get with while still being committed is generally better. It can be a 3-person team if all 3 of those people want to like commit a lot of time and a lot of work, because just having more people will allow you to have like less work per person, and maybe like so you can balance your school more and have more like time so you don't get like burnt out. The question is, how do you balance schoolwork and time commitment? I personally set a limit on like, it's different for everyone, but I can like set a limit of, all right, I look at the week and I'm like, all right, I have about this much work to do, and the rest of the time, or if I have like work or something, I can say, all right, I have this amount of time that I can do robotics, and I don't like bleed into that. And if I have a lot more robotics work to do, I'll just reach out to other people and say, hey, I need more time to do on schoolwork because I don't know, maybe it's a really big week for a lot of schoolwork. So, yeah. The question is, what are some things that coaches, not mentors, could help out with or have to do? So some of the administrative things like signing up for like signing up for events or signing up to get grants, or things that coaches can do, because maybe members don't really know how to do that. And also they can like organize meetings for like where your space is. Our mentor also runs the innovation lab at UCF, so he gives us access to the laser cards, the 3D printers there, and like a good workspace that we can work at. Mentor coaches also like can help give some ideas, or maybe just like help you along.
This question says, if a team member is unsure on what they want to do on a team, how can they surely know what they want to do? So I think to really figure out what you want to do is you have to be exposed to everything. So something that's really great to do is to give every single team member a basic overview and understanding of every different part of the team. So make sure that everybody understands basic hardware concepts, basic software concepts, basic engineering notebook stuff, and then kind of let them explore that for a little bit, and then kind of let them figure out, hey, where do I want to be? I know personally, over 7 years, I've done a lot of different things, and it takes a little time sometimes to figure out exactly where you want to be. So just let people explore where they want to be, and if at the beginning of the year they say, I really want to do hardware, that doesn't necessarily lock them into doing that for the next year. Make sure you let people kind of bounce around committees to really find where they fit best.
So the question is the robot or the notebook more important? They're both really important. Some people kind of choose to prioritize like the robot, and some teams just like don't focus on the notebook at all, and they focus on moving through the competition just by having a really really good robot. I would recommend focusing on both, because the notebook is really important for like a lot of awards. But obviously the robot is important as well, just to compete in the game. So
so the question is, can you please share some tips for competition day preparation? So one thing that you're probably going to be doing for the day before competition is you're going to be packing all of your stuff. You're going to be packing your robot, your notebook, all your tools for your robot. Because if your robot breaks at competition and you have no tools, you're yeah. You're gonna have you make sure you pack your safety glasses. At every FTC competition you go to, everyone, so your team members, your coaches, your mentors, your parents, everyone there, everyone there who's representing your team has to wear safety glasses.
Also, make sure you bring both controllers, because there were two meets that we only got one controller, because that was just the one that we had in our car. So we had to ask other teams, one of them being Super 7, for another controller. So yeah.
Something that really helps competition days is setting up checklists. So figuring out exactly what you think you're going to need before you get there, and kind of go through, say, hey, I think we should bring this many screwdrivers, go through and check it off, and keep it in like travel bins that you can take with you. So you have a lot of those supplies that you're going to need to make quick fixes throughout the day, and make sure you have, different hit setup stuff, and really checklists will help with that a lot.
Yeah, and if your team ever forgets something, you can ask different teams around you. They'll be happy to help you out. Another thing is the day before your competition, you're probably going to be testing out your code in your robot. So make sure you finalize all of your code before competition. During competition, you may make some minor changes based on how your robot runs, but you never want to make drastic changes at competition, because you won't have that much experience using those changes. Another thing is you may want to do some driver practice before competition. So have your two drivers and your coach, and next year also human player. Have them have them drive around, do some practice matches with just your team, and make sure that your team is prepared with all your stuff. Print out your notebook if your team is doing it online. If your team is doing your notebook online, and make sure that if it's league championships or state championships or worlds, make sure that your team knows what you're saying for your judging presentation, and make sure that your team's prepared for that.
Okay, so the question is, how many miles does one have to drive on average for competitions? Well, that completely depends on where the competitions are being held. Like, it depends on your region and like your league. So we're like in Space Coast, like us, Haggerty, and Z.I.P Ties. So we don't usually have to drive that far, but it just depends on where they're being held. When you get to state competitions and like national competitions, those are in predetermined locations. So it may be quite a bit of a drive. You may need to take some rentals or things like that. But usually the driving isn't that much of an issue. And then another question is, I've heard of rumors of secret judges. Is that true that there are? Well, not necessarily, I would say. But the thing is, when you're at an FTC tournament, you should always be displaying the principles of gracious professionalism, even if nobody's watching. And that's actually one of the big things about gracious professionalism. So it's very important to keep that professionalism within like your behavior as you're going through your day in the tournament. So there aren't necessarily secret judges, but people are watching what you do. Like, I know in FLL they always said there were secret judges, but in FTC you'll see all the judges who are there. But even though you don't see them, they might see you when you're doing something. So I would just say just be on your best behavior at competitions.
Okay, so one question is, do you have arguments in your team meetings and how you resolve them? I'm pretty sure all teams have arguments at some point. It's just how it is. What you want to do, if your team has an argument, let's say like about what robot strategy to use, make sure that you, like what we do is that when we have like a disagreement on like, let's say which part of the game to prioritize, we each come up with the pros and cons of what we're thinking. So if we want to say prioritize autonomous, we might say it can help you get more points, and then it's more valuable for alliance selection. So make sure that you like calmly discuss your topic, calmly discuss the pros and cons with the people, because if you just start yelling at each other, nothing's gonna get done, and you're just wasting time. So just try to calm down and see the value in what they're saying, and see what have them see what you're saying.
So this question is, some teams I know stay up late before the day of the competition. Should you do that? Should you, if you want to get lots of sleep the night before and be well rested? No. Is it very likely that you will stay up late before the competition? Yes. Usually the night before competition is when everything goes wrong. Robot pieces start falling off, programs stop working. So if you don't want to stay up late the night before the competition, you really have to make sure that you're working hard, like way before like the week before, to make sure everything's reliable before that night. But usually, procrastination happens, stuff gets pushed off because it takes longer, and the night before is usually when everyone's trying to get everything done really, really quickly. So you probably will stay up late the night before, but if you don't want to, make sure you're working hard before that day.
And one tip, as like there are a lot of people on a team, so try not to make your drive team stay up late, since they're going to be the ones that are actively controlling the robot the next day. If it's possible, like they're not programmers or like builders or something, try to let them sleep early, and then if anything else is needed, the rest should be taken care of by the rest of the team, just to help them out, kind of.
All right, so another question is, do you ever practice or scrimmage type meetings with other teams? Yes, we do. We either we set up or we have other teams invite us to go to scrimmages that are just a field set up with a bunch of teams coming over to just run their autonomous against each other, run their telepath against each other. And it's really good to have that actual experience, because there's only so much you can do in your lab that you can control everything that happens in your lab, but you can't control if there's 3 other robots running around and maybe trying to and maybe blocking your robot. Maybe you didn't think about your autonomous. It actually runs into a robot. We should probably fix that. So
If there are no more questions, then thank you for everyone being here. This has been such a great experience for me and all of us here. I would like to thank the Space Coast League commissioners, Mr. Nathan Bell and Mr. Andrew Rudolph, for just allowing us to do this and sending out the flyer and information about this webinar to many of you. Director of Jeunesse, Lucy West, all of our amazing presenters, Super 7, Necromancers, Metamorphosis, and last but not least, all of you for attending this event. Thank you.